This is part of the application development series of our channel. Hi, and welcome back, Open Data Divers. I'm Tim with Open Data Technology Services. Today we will continue where we left off in the last video. We will show you how to apply the techniques presented in the prior videos to an additional data set in a different region of the world that uses an API technology we have yet to encounter. In this example, we will hop the Atlantic Ocean to the Open Data Catalog for the city of Paris, France. This exercise will go towards further supporting the techniques and methods we are applying to the datasets can be used anywhere regardless of location and now language. As presented in our last video, we intend to travel the world in these exercises, with Paris being the third stop out of the 4 in the map plotting series of our videos. We begin our project by locating the Open Data Catalog for the city of interest. We do a Google search for the city, which is Paris in this case, combined with the keywords Open Data. The Open Data site is the very first result in the web search. Click on the link referring to Paris Open Data. Once redirected to the site, we encounter a surprise. The whole site is in the French language, which makes it a bit more challenging if English is your only language. A helpful tool in this exercise that comes with the Google browser is a nice feature that will allow you to toggle the translation of the site content from French to English. In this exercise, we are interested in plot mapping the popular bike and terminal data provided by the city. There are a few ways to locate this data set, but the quickest is to scroll down to the bottom of the home page where it is referenced as the most popular data set, having over 6 million downloads. We can also search for it in the Open Data Catalog search interface by searching for the word bicycle. It will immediately show up in the results as the top record. In the results of the search, Paris provides excellent, well-organized information on their datasets, which is very helpful during the research and discovery phase of an Open Data Catalog. Drilling down on the Open Data link for the bike and terminal records, we see that we can now explore the data set to ensure that it contains the geographic data to be able to plot on our map. This data set provides the proper longitudinal and latitude geo-coordinates of the bike and terminal information without needing any additional conversion to be plotted out. Paris chose to use the ODS API technology as the Restful Web Service method to share the data. ODS stands for Open Data Soft. ODS is filled with excellent examples and documentation on how to use their programming APIs. I have to say that ODS is one of the better Open Data API technologies we've encountered. Our next step is to identify the URL endpoint of the catalog to add to our application when processing the data. We will share this endpoint and the query filters used in the description of this video. Convert the JSON to a class object in our application for processing and manipulation. Develop the code that makes a RESTful web service call over HTTP and then processes the JSON formatted data into our class object to prep it for the next stage of the data's journey. Once our backend is coded, we can debug and check and make sure the code is correctly retrieving and consuming the data in our application. As mentioned in the prior series videos, it's a common occurrence that the data may need to be programmatically manipulated at this portion of the application development phase. In this case, we had to make some adjustments and add the latitude and longitude coordinates to make it easier to work with our front-end coding. We now programmatically tie all the data into our front end and prepare it to display on a map. In this example, we will only display a few data fields of interest in our map marker pop-up window. We've decided to utilize marker images relevant to the data we're displaying. Since our data is dealing with bikes and terminals, we will be using cycling icons as our plot point marker. After the back-end and front-end code is complete, we can now test the results of our application to ensure that it's doing what is expected when we execute it. We test the map plotting and marker data of the code we just developed. As you can see, the plot points have been positioned on our map with the center location adjusted to show the city of Paris. We can now click on the markers to examine the data displayed in the pop-up window upon a click action. In this example, our pop-up window displays the following data fields related to the record: the terminal name, the station code, e-bikes, mechanical, and is renting. To further show that language barriers do not matter as much when working with processing data, we've done the same plotting exercise with the planning authorizations in the city as well. This shows much more information about each record point. As you can see, we've added the descriptions of each planning permit request, and there's plenty of French language now included in the pop-up windows for the markers. Some additional features we've added to our map during this exercise include adding the map type controls in the top left, adding bicycle data layer which relates to the bike and terminals, and combining data sets by plotting the bike and terminal data with the planning permit request data on the same map. We will continue building off the combining data set concept in our final video of this series. Please feel free to add a comment below if you would like to provide feedback on our projects. You can also make suggestions of particular datasets you would like us to explore in future videos. Thanks for watching the full video and stay tuned as we wrap up our map plotting series in the city of Melbourne, Australia. I hope you have a wonderful day and please subscribe so you can be informed on when our next videos are published.